Hello again. This is day 19 of Advent of Code. So we solved 18 yesterday, it was pretty straightforward. Let's see how 19 is treating us today. And I'm really sorry about the poor quality of the stream. I'm not at home, the internet is not as fast here as I wish for it to be. I'm streaming low frames, but this seems to be the best I can get. So let's hope with a large enough font you can read something. Day 19, go with the flow. If not, I'll be back in early January, back to the regular good internet, better stream. I don't know yet what I want to stream once Advent of Code is over, but yeah, maybe one of you has an idea what would be a fun stream to watch and to do. Should also be fun to do for me. All right, day 19, go with the flow. With the elves well on their way constructing the North Pole base, you turn your attention back to understanding the inner workings of programming the device. You can't help but notice that the device's opcodes don't contain any flow control like jump instructions. The device's manual goes on to explain. In programs where flow control is required, the instruction pointer can be bound to a register so that it can be manipulated directly. This way, set register, set immediate can function as absolute jumps, add register, add immediate can function as relative jumps, and other opcodes can cause truly fascinating effects. Okay, this mechanism is achieved through a declaration like instruction pointer 1, which would modify register 1 so that accesses to it let the program indirectly access the instruction pointer itself. Ooh, okay. To compensate for this kind of binding, there are now 6 registered, numbered 0 through 5. The 5 not bound to the instruction pointer behave as normal, otherwise the same rules apply as the last time you worked with this device. Yeah, because we had this really fun challenge, I think on Sunday, with the opcodes. When the instruction pointer is bound to a register, its value is written to that register just before each instruction is executed, and the value of that register is written back to the instruction pointer immediately after each instruction finishes execution. Afterward, move to the next instruction by adding one of the instruction pointers, even if the value in the instruction pointer was just updated by an instruction. Because of this, instructions must effectively set the instruction pointer to the instruction before the one they want to execute next. Yeah, that makes sense. The instruction pointer is 0 during the first instruction, 1 during the second, and so on. Okay, so it's indexed 0 base. The instruction pointer ever causes the device to attempt to load an instruction outside the instructions defined in the program instead immediately halts. The instruction pointer starts at 0. It turns out that this new information is already proving useful. The CPU in the device is not very powerful and the background process is occupying most of its time. You dump the background process's declarations and instructions to a file. You puzzle input, making sure to use the names of the opcodes rather than the numbers. For example, suppose that you have the following program. Okay, instruction pointer is bound to register 0. Set immediate, we set the value of 5 to register 1. We set the value 5 into register 1. When executed, the following instructions are executed. Each line contains the value of the instruction pointer at the time the instruction started. Oh yeah, so register 0 always has the instruction pointer, so in the first one it has 0. The instruction itself and the value of the 6. Okay, so IP is 0, we're starting at 0. That took me a while the last time to figure out that that's a starting register, but that's how we start. And, oops, in the zeros register, no, yeah, IP 0, and so in the first register, it's the instruction pointer. Now we want to set value 5 into register 1. So this 0 doesn't change, but the 5 goes to 1. It updates register 0 to the current instruction pointer value. And so the first sets register 1 to 5, sets the pointer to the value of the first register, no effect, and then adds 1 to the instruction pointer. So now we have instruction pointer 1 in here, and we set value 6 into register 2. Okay, we increase this to 2. Now we add immediate, so register of 0 plus immediate of 1 into register of 0. So this register has now value 2 plus 1 is 3. We put that into the first one, we leave the other ones untouched. Now we increase this to 4. So we're jumping to the fourth instruction. 0, 1, 2, 1, 2, 3, 4, and we leave out the 1, 2, 3 because we skipped over it, which is, oh, that was the add 1, which was the relative jump, and now we do a set register, which should be an absolute jump. So we want to set register, the register in 1, we set that to 0, so this 5 moves into here. Now we increase the pointer by 1, so it's a 6. So now we jump absolute to the 6th instruction, which is 905. Set immediate, so we're setting the number of 5 into register 5 back here. Okay. Yeah. Oh, okay, the instruction pointer is 6. We increment it to 7, but we don't have an 8th instruction here, so now the program halts. What value is left in register 0 when the background process halts? All right, so background process halts. What is left in register 0? So here it would be a 7. Yeah, so here it would be a 7. Okay. All right, where's my puzzle input? This is just a sample. Let me just copy that real quick. And then let's get the real input here, get your puzzle input. Okay, so the IP is in 2. Oh, that's not too long. That doesn't look too bad. And this is input day 19. And now I was copying over day 18 into day 19, but maybe I should just copy over day 16. Day 16 to day 19. Because I want to say 16, was 16 the one with all the opcodes? Yes. Okay, and we want to use day 19, but we're working on the test input first. Inputs is this, and then we're just returning inputs. Initialize main let inputs is equal to this. And the first line that we're reading will always be yep, DID. Okay, what did we have with the opcodes here? I had all 16 opcodes and I was just pushing them in there. And I think I don't want to push them like this. I think what I want to do is, so first of all, we don't need, ooh, what did I do? We don't need this line here. You put it right here, but let this be a map. And I don't want to push. I think what I want to do is I want to set oops. Bummer. What were those called? They were called opcode. How does this look? Let map. Well, that's not valid JavaScript. New map. So I'm adding all those, and I believe, yes, they all have lower cases. So let me just quickly do that. Bori. What was Bori doing? Oh, bitwise and an or. Then we had these greater thans, and we had the equals. Okay, so now I have my opcodes in the map. I can easily get them out. And now I need to parse the input. So first thing we need is the let instruction pointer is equal to, we're taking inputs that shift, that match, and now we want to match, no, that split at the empty spot. And of this we want to take the second entry, and don't want to make this mistake again. It definitely needs to be a number. Where am I calling initialize, or rather what does it do it? What was initialize doing? Pretty sure I don't need to run this, but let's keep the function in here just in case. I'm reading the input. I have my list of opcodes in here. I have an instruction pointer, which should look something like this. So I'm taking the first line, I'm just shifting this out, and I just want to make sure that that's right. So let an area 1, 2, 34. A, that shift is the first one, and A is shorter now. Yep, that looks good. Was a quick test. Okay, and so now for the other ones, yeah, my input always looks like this. All right. So for let line, for every input, what do we do? I think we're just processing the registers right away. Let register equal 1, 2, 3, 4, 5. Do we have 5 or 6 inputs? What was this question? Oh wow, I'm looking at the stream. I can literally not read anything. Let's hope it gets a little better. How is it for you? Can you see anything at all, or is it just listening? Okay, but there's actually 6 of them. So the registers, there's 6 of them. And the first instruction pointer, I guess in my example is going to be 2, but that really shouldn't matter. So for every line, which looks like instruction, A, B, and output. So let's say instruction A, B, output is equal to line that's split, and we're just splitting at these spaces. And then we want to map this to the number function. What happens if I map something that's not a number? So A that push set I, A that map number. Yeah, that did not work. I was afraid I could not just do that. So let's do this. Let instruction equal to line dot split first entry. All right, so we have A, B, and the output. And now we want to call A, B output. How do we change the next register? So I want to say register of output is equal to opcodes that get of instruction applied to A, B. That's the register output. And register of instruction pointer is equal to its previous value plus 1. And I realize what I'm doing now. Now I would, since I'm in a for loop here, I would be going on to the next line. Of course, I can't do that. I have to take the next line at that position. So let's move those out. And for every line, what is a line like that called? Is it an instruction or is it an opcode? So I think this is the opcode. Let instruction equal an empty array. And then I want to say instructions that push, and I'm pushing into this. Yeah, I'm just pushing the full array of the instruction and then the numbers A, B, and output. And really what I want to do, I don't like that. Taking this, and then I'm taking number of A, number of B, and number of the output register. I think I like this better. Ops A, B, and output, I'm pushing those into the instructions. And now while the instruction pointer is less than instructions dot length. Yep, so while this is inside here, and I don't know if this can happen, but instruction pointer bigger or equal to 0. So while all those are good, this should really be further up. This is just a quick check that I added all of them. This is my initial register. All right, so we're starting with instruction 0. And we get this by saying let instruction is equal to instructions of the instruction pointer. Okay, so we have an instruction, and then we do, but really the instruction is this, and it's already an array in here, so I don't need to split this anymore. And then register of output is opcodes get instruction ops of A, B. And then once I've set that, then I'm setting register of instruction pointer is equal to its previous value plus 1. And now I'm updating. Wait, am I increasing that register, or am I only increasing the instruction pointer? I need to double read that. Doesn't your opcode function return the whole register? Oh, it might. Let me double check what my function is doing. Because in that case, I have to rewrite these opcode functions. All right, but let's go back to the instructions here. When executed, the following instructions are executed. Each line contains the value of the instruction pointer at the time the instruction started. So where is that thing? The instruction pointer contains 0, and so the first instruction is executed. Okay. And then it sets register 1 to 5, sets the instruction pointer at the value of the register, which has no effect, and then adds 1 to the instruction pointer. Does it update? Wait, instruction pointer is at 0. Why is this a 1 now? We're setting the value 5 into the first one. Then we're updating the instruction pointer and set that to the register. So we do change the register. Let me just double check I understand that. Instruction pointer is 4. Instruction pointer is 4, but we have to increase it. Right, yeah, is 4 into register 0, which causes it to end up in the instruction pointer. It's then incremented, leaving it at 6. Yeah, so we do, I guess if it has a pointer in it. So I'm just a little bit confused about the wording, but I think since we have a since the instruction pointer is it's a pointer to the register, and we are upgrading that pointer, but it is in the register. So am I doing this correct? I think I'm not doing this correct. The instruction pointer. Oh, that's the instruction register, it's not the pointer. So this is the instruction register, which is in my case always 0. And we are starting with let instruction pointer is equal 0. I'm just going to call this IP. Okay, so the pointer is 0. As long as the pointer is within range, we're grabbing the instructions. We're grabbing that ith line, and then we're running the opcode, which I need to check if it only returns the output or everything. And now I want to say IP is the register of the instruction register, and then IP equals IP plus 1, and also register of the instruction register. I'm setting that to this new IP value. And then I'm running this until it fails. Whoa, lots of stuff happening here. And then if it did fail, I want to print register of 0. Where am I setting? Oh yes, the register is set here. Do not need this up here. Don't need this anymore. So now let's just look at what these opcodes look like. Opcodes of I. Oh, it always returns the before. I don't want to return the whole thing because these didn't have the same amount. So I just want to return that value here. Does that look right? Am I thinking the right thing? I'm not returning the whole next line, I'm just returning that one value. Yeah, so Finn, instead of writing something else, oh my gosh, you can't read anything in the screen. Yeah, but instead of writing something else I'm just changing these functions. There's only 16 of them. Can't be that hard. And it's even making the code shorter because I'm deleting these 16 lines. Am I done yet? Assign copies of value A into C. Wow. All right, 16 is actually quite a lot. Okay. All right, I'm adding all those to the map. I'm checking if they have the right length. I'm setting the instruction register, which is the second part in that thing, converted to a number. Now I have a list of instructions and I put all the lines in the instructions. I have a starting register. I have a starting instruction pointer while that instruction pointer is in a valid range. I take the instruction at that position where the pointer points to. I'm setting the output to whatever the function evaluate, the opcode evaluates to. Now I'm saying IP is the new value at the instruction pointer register. I'm increasing IP and I'm setting the instruction register to that new value. There's probably some smart inline incrementation, but that might also be terrible. Okay, did some formatting and then I'm printing this. All right, I'm running this on the test input. So let's see what happens. Node A19. Counting is hard. All right, I'm glad I still have that in there. And I know what went wrong. I had an array before. Now I'm checking for the length. So let's just make sure this works. Okay, cannot read property 0 of undefined in line 45. Uh, 45 return. Oh, I'm always passing in the whole register. Am I not passing that in here? Okay, so what? All right, I need to rewrite the rest of these functions too. Because right now I'm passing in A, B, and output, and a before. I don't want to do that. What I really want is this, 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 this. And I really want to be here. Multi-line editing. Well, multi-line editing over 16 lines still takes a while. Okay, so I don't want the output. Do I want the before register? Do I want to call it something else? Okay. Chat, you actually don't need to change the function at all. Works fine if you leave them the same as day 16. Yeah, I probably should not have changed them, but I wanted to use a slightly different syntax here. So it's too late now, I already changed them. How do I get the current register? Oh, the current register is what I'm working with. It's not related to these instructions. So I'm passing in the register and it returns the output, which I'm just setting here. Yeah, I should have just left them the way they were. Oh well, bummer. Okay, and it is a 7. Was that actually the right number? I think that was pretty close to what we had in this example. The instruction pointer is incremented, so it was 6, it's incremented to 7, causing this to fail. All right, let's see what this does on the real input. 1248. I don't know. Don't have a good feeling about this number. What do you think? Oh my god, that was right. All right. That was a lot easier though with your help here on the chat, because otherwise I would have been looking for these little typos or misremembering what it used to be. All right.